A powerful motor can still produce an unsafe, unreliable conversion when the controller, battery, frame, brakes, or wiring are poorly matched. Motor wattage indicates performance potential, but it does not confirm that the complete system will fit the bicycle, manage heat, deliver predictable control, or withstand axle torque. Start with the intended use. Flat commuting, steep climbing, cargo transport, trail riding, and fat tire operation create different demands for cooling, braking, battery draw, and low-speed control. The riding environment also affects whether a high-power conversion is appropriate under local rules. Only after defining the use case should motor output become part of the buying decision. Inspect the electrical system as a matched package. Battery voltage must suit the controller, the charger must suit the battery, and current ratings must be clear. For a 72V, 3000W platform, controller selection directly affects acceleration, heat, cable load, and battery stress. Higher current may increase launch force, but it also increases thermal and mechanical demands. The controller should have documented battery current, phase current, connector layout, display support, sensor compatibility, and thermal provisions. Photos or wiring diagrams should identify connections for the motor, battery, throttle, pedal assist sensor, display, and brake cutoffs. Physically compatible plugs are not sufficient because pinouts and voltage logic may differ. Control quality matters just as much as raw output. A throttle should provide progressive response without abrupt launches or dead zones. Its connector needs secure retention and cable strain relief. The display should provide readable battery information, voltage visibility, assist settings, trip data, and fault codes. Voltage visibility is particularly useful because a simple battery bar may be imprecise. Pedal assist must engage and disengage predictably. Check crank area fit, magnet alignment, response delay, sensor placement, and whether assist levels can be adjusted. A system that continues driving after pedaling stops or surges during low-speed balancing can make a strong motor difficult to manage. Brake cutoff sensors should interrupt drive immediately and consistently when braking begins. Confirm whether the kit supplies compatible replacement levers or add-on sensors for the existing brake arrangement. This function helps control throttle errors, delayed pedal assist, emergency stops, and low-speed maneuvering. Mechanical fit is another pass-or-fail area. Verify wheel size, rear dropout width, axle seating, brake format, rotor clearance, tire clearance, drivetrain layout, and cable exit direction. Axle flats should seat fully without forcing the frame. Battery placement must also account for available frame space and secure mounting. A torque arm is not optional decoration on a high-power rear hub conversion. It transfers axle reaction force away from the dropout and into a stronger frame area. Frame material, dropout depth, terrain, rider load, controller settings, and launch behavior all influence the required retention strategy. Dual torque arms may be appropriate where fit is shallow, the frame is less forgiving, or operating conditions are severe. The AbleBike 72V3000W rear hub kit illustrates how a detailed product page can support inspection. Its listing identifies a 72V30A triangle battery, 84V3A charger, Saviton 60A controller, UKC1 display, twist throttle, pedal assist, brake cutoff levers, torque arm, wheel options, and 135mm installation width. Each listed item should become a verification point rather than an assumption of compatibility. Before purchase, request rating labels, connector photos, wiring diagrams, wheel and dropout specifications, display information, warranty terms, replacement part availability, and installation guidance. Missing evidence does not automatically mean poor quality, but it increases the inspection burden. Clear critical risks before considering price, styling, or speed claims. If the motor fails to run after installation, the buyer should already know which component to test and what information can identify the fault. A complete kit is not merely a motor surrounded by accessories. It is an integrated electrical, control, mechanical, and safety system whose weakest mismatch can determine the outcome.